All right, are you ready to get a handle on calculus? You are in exactly the right place. We're about to do a quick, high-level review of all the key ideas from Chapter 1. Think of this as our final pre-flight check, just making sure everything is solid before we really take off. Let's dive in.
You know, when you boil it all down, this is what calculus is really about. It's the language we use to describe change. It doesn't matter if it's the motion of a planet, the growth of a population, or any kind of transformation, this is the tool for the job. Everything we're about to cover today is built on this one powerful idea.
So why does this matter? Well, because change is literally everywhere. I mean, from planetary orbits to the Richter scale for earthquakes, calculus is what lets us make sense of it all. Those logarithmic functions we're going to talk about, yeah, they're the reason we can even measure the awesome power of an earthquake. This isn't just abstract math. This is math that models our reality. Okay, here's our game plan. First, we're going to get the vocabulary down, the language of functions. Then we'll move on to the essential equations, our mathematical toolkit. And finally, we'll tie it all together by looking at the big ideas from the chapter. By the end, you'll have a super solid foundation for everything that comes next.
Let's start with the language of calculus. To really get good at this, you've got to know the lingo. So we're about to flash through the 50 key terms from this chapter over the next few slides. Now, I'm not going to read every single one, so just feel free to hit pause and review any definitions you need to brush up on. Ready?
First up, the absolute fundamentals. This first set of terms covers the core stuff, like what a function even is, what its domain is, and the whole relationship between dependent and independent variables. Seriously, these are the building blocks for everything else.
Okay, now we're getting into some more specific tools. See the horizontal line test on this slide? It's such a simple but brilliant visual trick to see if a function is one-to-one, and that's a super important property we're going to need later for inverse functions. Again, don't be shy about pausing if you need a minute here. This set introduces us to a few different flavors of functions. You've got your straightforward linear functions, but also those more complex piecewise defined ones. And hey, let's not forget the famous number e on this list. It's the foundation of the natural logarithm and really a cornerstone of calculus.
And here we have even more essential building blocks. We're looking at different ways to write equations for lines, the definitions for polynomials and power functions, and that all-important concept of a function's range. Trust me, all of this is crucial for what's coming up. And here's our last batch of terms. This list covers concepts like symmetry, transformations, and the vertical line test. So, now that we've got the vocabulary down, let's look at the tools we can use to actually put these ideas into action.
All right, time to open up the toolkit. This is where we put all that new vocabulary to work. These are the key formulas from Chapter 1 that you'll find yourself using again and again as we move forward. This first set of equations is all about how we can manipulate and combine functions. We've got composition, which is kind of like nesting one function inside another, the absolute value function, that super versatile generalized sine function, and the defining property of inverse functions. It's all about understanding how these functions relate to each other. Here we've got the essential forms for some of our most common functions. You've got the 3 classic ways to write the equation of a line, plus the general form for any polynomial you can think of. These are the fundamental structures you're going to be working with constantly.
Okay, we've covered the language and we've covered the tools. Now it's time to put it all together. We're going to summarize the big ideas from each section of the chapter. This is where the magic really happens. So, section 1.1 was all about the basics, right? The key takeaway is that a function has exactly one output for each input, and we can easily check that with the vertical line test. We also covered domain, zeros, function composition, and the 2 types of symmetry, even and odd. Next up, section 1.2. This is where we started to categorize our functions. We looked at power, root, and rational functions, and we talked about that important difference between algebraic and transcendental functions. We also saw how transformations, like shifts and reflections, can totally change the graph of a function. Then we dove into trigonometric functions. The big ideas here are all about radian measure, defining trig functions using either right triangles or a point on a circle, and their repeating periodic nature. One key thing to remember is that sine and cosine repeat every 2 pi, but tangent actually repeats every pi. Section 1.4 was all about inverse functions. The main point here is that a function has to be one-to-one to even have an inverse, which, as we know, we can check with the horizontal line test. Sometimes that means we have to restrict the domain to make it work. And oh, don't forget, a function and its inverse are always perfectly symmetric about the line y equals x.
And finally, Section 1.5 brought in the heavy hitters, exponential and logarithmic functions. These two are inverses of each other. The exponential function, y equals b to the x, grows when b is greater than 1, and its inverse, the log function, is just an incredibly powerful tool for solving equations, especially when you use the change of base formula.
And there you have it. We've walked through the vocabulary, the equations, and the core concepts of Chapter 1. You now have all the pieces you need to really start building your understanding of calculus.
Remember how we started with that idea that calculus is the language of change? Well, you now have the vocabulary, the tools, and a conceptual blueprint to start speaking that language fluently. Think of this as your launchpad.
So, as you move forward into the rest of calculus, I'll leave you with this question. With this new foundation now solidly built, what change in the world around you, big or small, are you going to choose to describe? Thanks for joining me.